class of chemistry. As we had already started with the structure of atoms, today we shall proceed with the future concepts. Now, I have already taken a liberty of drawing the figure. In this particular case, what we have is, this is a vacuum chamber here. Right? So this is a vacuum chamber which is usually made up of a glass, and over here what we have is a clean metal, right? So it is a metal foil, what you can say, a clean metal foil we are keeping over here, and this is of course battery. This is a battery, and over here is the emitter. And finally, what we have here is an important thing which we call it as the detector. I haven't mentioned about the name of this concept, but soon you will understand it. Now, when we are taking a look into this particular apparatus, what happens here is that whenever a radiation of suitable frequency, I repeat again, whenever a radiation of suitable frequency is incident on this metal foil, metal surface, what happens is an electron is ejected out from this metal surface. This particular electron, which has been ejected out from the surface of this metal, we call this particular electron as the photoelectron, right? So this is your photoelectron here. So what is happening? A particular radiation of suitable frequency is incident on the surface of a metal, and this particular metal, what is happening? It is giving out an electron. Now this electron which is coming out from the surface of this metal, we call it as a photoelectron, and this entire concept, we call it as the photoelectric effect. So, what is a photoelectric effect? A photoelectric effect is a phenomena wherein a radiation of suitable frequency is incident on a surface of metal, and that particular metal gives out electron. And this electron which has been coming out or ejected from the surface of this metal, we call it as a photoelectron. Now this photoelectron which has been ejected from this metal, this goes directly to the detector. So the detector will tell us how many number of these particular electrons have been ejected from the surface. That means these electrons directly travel to the detector, and the detector measures as how many number of electrons have been ejected from the metal upon the incident of a suitable radiation. Now this entire thing was performed by the scientist Henry Hertz. The person who started with this experiment was Mr. Henry Hertz, right? So there are several results wherein we have to concentrate. So what are the results here? The first result is that this phenomena is spontaneous. That means the moment a radiation strikes the surface of a metal, the electron is ejected. That means there is no time lag between this particular phenomena. So the first thing what we have to understand is the electrons are ejected. The very moment the radiation with suitable frequency, of course, strikes the surface of metal. So this is our first result, what we understand, that the electrons are ejected the moment a radiation strikes the surface here of a metal. That means, conclusion is that there is no time lag, right? So this is our first result here. Second thing that what we have to understand is, it all depends upon intensity, it also depends upon frequency. Now, understand this, the number of electrons ejected depends upon the intensity of radiation, right? Now, intensity in the sense we are speaking about the brightness here. Brighter the light that has been incident on this metal surface, more the number of electrons are ejected out. This is what it says. So, second result is the number of electron goes on increasing if we are going to use more brighter radiations. Correct? So, the third number what we are going to focus is the result number 3 is that the kinetic energy of electron, of course the electron is coming out, that means this electron what is coming out has a certain amount of velocity with it. That is, it is going out with certain amount of kinetic energy, right? So now the kinetic energy of this particular electron, it depends upon the frequency of radiation. So, higher the frequency of this particular radiation, more is the kinetic energy of the electron what is going to be ejected out. So, we have 3 conclusions here, 3 results. That is, the first one what it says is the number of electrons ejected the very moment a radiation strikes this particular surface of a metal. Second point what it says is the number of electrons ejected becomes more when the intensity of this radiation is brighter or higher intensity is being used. Third point what it says is the kinetic energy of this particular electron goes on increasing if we are going to use a radiation with higher frequency. Right? So these are the important points what we have to remember. So first one over here that there is no time lag. Right? The very moment electrons are ejected, the moment the radiation strikes the surface. Second point is the number of electrons ejected goes on becoming greater with the intensity of radiation. These are the important points. And of course, the third one is kinetic energy. Kinetic energy of electron goes on increasing with increase in the frequency of radiation. Remember, frequency of radiation is nothing more than the energy of radiation. Right? So, we will proceed with this particular thing again. This particular phenomena was again explained by Sir Einstein. But this time taking into consideration of electromagnetic radiations into consideration. So therefore, what Sir Einstein says is that whenever that there is a radiation that is striking the surface of a metal, he says that if this is a radiation that is going to strike a metal, then this radiation is going to have small packets of energy which is already been called as the photons. Right? So, Sir Einstein says that the moment these radiation strike the surface of a metal, it transfers its energy at an instant to the electron at this particular point of collision. Therefore, this particular electron comes out over here when the energy is being transformed from the photon to the electron. So when a photon comes, collides, it transfers its energy to the electron. This electron takes that energy and comes out from the metal, right? So therefore, this particular electron which is coming out over here, he calls them as, of course, the photoelectron. Right? So we will understand this particular concept of the photoelectron much more into details now. So we will draw a figure over here. Let us say that this represents a nucleus, right? Let's say these are the orbits. Let us say these are the orbits. Now, let us say that this is the electron here. One more electron over here will take. One more here. To here. Okay. Let's say this is a particular representation of the atom. Okay. Now, what is happening is a radiation is coming. And this is striking. Of course, if we are speaking about a metal surface, what will metal have? Is nothing more than the metal is going to have an atom, and this is the representation of an atom, right? So, when a radiation of suitable frequency comes and collides with that metal surface, that time, whichever the electron comes in a path, the photon transfers its energy. The photon transfers its energy to this electron. It's transferring. Now, this energy which has been transferred to the electron, this energy is utilized into two different manners. A part of energy which has been transferred to this electron is utilized in coming out from the attractive power of this nucleus, in coming out from the binding energy of the nucleus. Okay, so the energy is utilized in two different parts. A bit of its energy is utilized in overcoming the attractive power from this particular nucleus, which is nothing more than the binding energy. To overcome the binding energy, which we usually denote it by W. Alright, and a part of the energy of this photon is utilized for the kinetic energy of electron. Alright, so can we take this particular expression and convert it into an equation now? That is, the energy is going to be classified into as h nu, that is, energy of photon is going to be utilized as h nu. What is h nu? We will see it. Plus half me. Me refers to mass of the electron. Me v square. Right? So this is nothing more than your binding energy W here. Now, try to understand this. Every single metal that what we take has a characteristic phenomena. We cannot use any radiation on that and can expect the electron to come out. No. Every single metal has a characteristic frequency. A particular radiation with that suitable frequency or more greater frequency than that only can show us photoelectric effect. If the particular frequency of the radiation is lesser than the limit what is required for the metal, then no photoelectric effect is going to occur. Right? So therefore, the minimum frequency the minimum frequency of the radiation which is required for that characteristic metal in order to exhibit photoelectric effect, that minimum frequency we call it as the threshold frequency. So, threshold frequency is nothing more than given by nu naught. So, threshold frequency is nothing more than the minimum amount of frequency that is required in order to exhibit the photoelectric effect. Correct? So, therefore, for us, the energy of photon, this particular expression is very, very important.